Venn diagrams. Let's try to get a bit brief idea of it. Venn diagrams is one more way to represent a set. Up till now what we have seen? We have seen that if I want to represent a set, then I have to write it inside the braces. Inside the curly bracket if I write, then it is a set. If I write it like this, for example, if I write this 1, 2, 3, 4, 5, so on, then these are the set of natural numbers. Now what is the other way? The other way is by using Venn diagrams. What is it? It is a way to represent set graphically. Generally, if I want to denote universal set, then I would use a square or a rectangle. What is this? U is universal set. If I want to represent any other set, then I will use any closed region, but generally we use circle. This is a set. Let's try to now see how to represent using it. For example, I would take A is equal to 1, 2, 3, B is equal to 2, 3, 4, and universal set is equal to 1, 2, 3, 4, 5. Then first thing is you have to draw the universal set, which is a rectangle or a square, depending on what number of sets do I have. Now here I have set A, this is universal set, and this is set B. Now we will see what are the elements in set A. 1, 2, 3. What are the elements in set B? 2, 3, 4. So now if I now see here, what are the common region between this? This is the common region between A and B, and 2, 3 are the common elements between the set A and B. So if I want to write it here, then where should I write? In the diagram it should be in the region which is common in A and B. So I can write, okay, something went wrong, just a second. Okay, I will draw it once again, no worries. This is our set A, this is our set B, and this is our universal set. Now if we see, the common region is this, so 2 and 3 should be here. What is left? 1 and 4. 1 is only present in A, 4 is only present in B. Now if you take a look at universal set, this 5 is still left, so it could be written anywhere inside the universal set. So this is the representation of the system given here. This is a brief idea about Venn diagrams. Now again, if I want to denote union, intersection, then I can do all of it as well. Let's suppose, general case, there is a set A and B. Both of them are non-empty sets. There is a universal set U. Then if I want to represent A union B, then how can I do it? I know that A union B is either in set A or in set B. Then if I draw the system here, then A union B means what? Either in set A. That means either in set A or in set B. So everything inside this region represent A union B. If I want to represent A intersection B, what is A intersection B? X such that X should belong to A and X should belong to B. That means the common things, the common elements between these two sets. So now if I see here in the system, the Venn diagram, if I see, what is the common region between A and B? This much. So this is A intersection B. Now if I want to represent difference, let's say A minus B. What is A minus B? X such that X should belong to A and X should not belong to B. Then what can I say? I can say this is set A, this is set B. What is the region which is only A and nothing from B? Can I get this much? This is set A, but this much is what? Set A and nothing from set B. If I take this, then I would take the common region between set B. So I don't have to take this. Only the shaded region is A minus B, and the vice versa of it is B minus A. That means if I do B minus A, X such that X belongs to B and X should not belong to A, then this is set A, this is set B. Then this much region, sorry I went a bit outside. If it goes outside the circle, it is taking other region as well, so it should not go outside the circle. This is set B minus A. This was like a brief idea about Venn diagrams. Why do we use Venn diagrams? Because in some of the cases, it makes our calculation a bit easier than the general use of roster or symmetric method. Symmetric set builder form, sorry. That's why we use Venn diagrams. Once we solve the questions, you will see there are certain questions which could be solved using Venn diagrams very quickly in comparison to any other way. So this was the theory, the basic theory of set, and probably in the next class we'll try to do some questions on the basis of it.